Hi, this is George Woodbury from the College of the Sequoias in Visalia, California, and this is the fourth in a series of 6 videos I've put together to help my class review for their Elementary Algebra final. In this video we'll be taking a look at material from Chapter 5 that includes exponent rules and polynomials. Let's get started. First set of problems we're going to take a look at are 2 problems involving exponent rules. When we multiply exponential expressions with the same base, we add the exponents. So here we'll get c to the 8 plus 12 power, and 8 plus 12 is 20. When we have the same base in the numerator and denominator, we're looking to subtract the exponents. Keep in mind that if an exponent isn't written, it's 1. So here, 8 minus 1 will be the exponent for x, and 13 minus 6 will be the exponent for y. Both of those differences are 7, so we're left with x to the 7th, y to the 7th. Moving on to take a look at negative exponents, the result here should have not have a negative exponent in it. So at the end of the problem, if we have a negative exponent, we have to take care of that. We're going to begin by distributing this power of 2 to each base inside the parentheses. We'll multiply it by the existing exponents, but I want to talk a little bit about the base 3. When we bring in the power of negative 2 to the base 3, we need to write it like this, 3 to the negative 2. The biggest mistake that I've seen is that students will think that 3 to the negative second power is equal to negative 9, which it is not. To compound that mistake, students will see a negative 9 in the denominator, confuse it with a negative exponent, and move it to the numerator as a positive 9, which ends up with the right result for the wrong reason. So 3 to the negative second, we have to rewrite this with a positive exponent before we can raise it to that power. Okay, let's get started. Bring in the power of negative 2. Negative 2 times 4 is negative 8. Negative 2 times 7 is negative 14. Here's my 3 to the negative second power. Negative 2 times 5 is negative 10. And finally, negative 2 times negative 8 is positive 16. The expressions that have a negative exponent need to move to the other side of the fraction. So these two bases will move to the denominator, and the exponents will change to positive 8 and positive 14. These two bases, negative 2 and negative 10 as their exponents, will move to the numerator, becoming a positive 2 and a positive 10. The only base that stays put in this problem is d, because its exponent is already positive. So we'll move those around, and we'll finish the problem by replacing 3 squared by 9. The next group of problems involve adding or subtracting polynomials. I've chosen a difference here. When we subtract a polynomial, the first step is to distribute that negative sign through to each term in the second polynomial. This is going to become a negative 4x squared, a positive 3x, and a negative 16. Once we've changed all those signs, we can go ahead and combine like terms. X cubed can't be combined. There are no other x cubes. But we have 2 terms with x squared. Negative 5 and negative 4 becomes negative 9x squared. There are 2 terms with x. 17x and 3x become 20x. And finally, negative 16, the constant, will stay as is. And there's our final result. Polynomial multiplication, a lot of you know this is FOIL, but the thing you want to remember is you want to multiply each term in the first set of parentheses, that first polynomial, by each term in the second set of parentheses. So I'm going to distribute the 5 to 2x and 5, and then I'm going to distribute the negative 4 as well. 5x times 2x is 10x squared. Little typo there. 5x times 5 is 25x. Negative 4 times 2x is negative 8x. And negative 4 times positive 5 is negative 20. At that point, we need to combine any like terms. 25x and a negative 8x will combine to be 17x positive. And I'm sure I made the same typo here. Absolutely. So our final result, 10x squared plus 17x minus 20. For those of you scoring at home, you can go ahead and give me a -1 on that. Another common multiplication problem is shown here. You want to be careful. We cannot distribute the 2 into the parentheses because there's more than one term. When we have more than one term raised to a power, we have to begin by rewriting this as the product of 2x minus 3 and itself. Recall that squaring an expression means to multiply it by itself. Now we'll go ahead and multiply this out. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is negative 6x. And negative 3 times negative 3, positive 9. Finish by combining like terms. Negative 6 and negative 6 will make a negative 12x. And there's our final result. Okay, the last problem in this chapter, everybody's favorite, long division with polynomials. The denominator is the divisor and goes outside the division box. The numerator is the dividend and goes inside the division box. First thing we have to figure out, what do I multiply by 3x that will give me 12x squared? Or in other words, what is 12x squared divided by 3x? Well, 12 divided by 3 is 4. X squared divided by x is simply x. So I'm going to write 4x in the quotient. Multiply 4x by 3x minus 5 and write the result here. 4x times 3x is 12x squared. 4x times negative 5 is negative 20x. Now we need to subtract, and the way we can do that is by changing the signs. Negative 12x squared, positive 20x, and combining the like terms. Negative 11 plus 20 is a positive 9x. Bring down the next term. Lather, rinse, repeat. We'll do the same thing again. What do I multiply by 3x to get 9x? A positive 3. 3 times 3x is 9x. 3 times negative 5 is negative 15. So again, that's 3 times 3x minus 5. To subtract, I change the signs and combine like terms. And I'm left with a remainder of 30. The way that we write our remainder, it's positive, so I'm going to write plus. The remainder in the numerator, the divisor 3x minus 5 in the denominator. And here's my quotient. If you have any questions or comments, go ahead and leave a comment on the video, or you can reach me through the contact page on my website, georgewoodbury.com. Thanks and good luck.